Okay guys, welcome to this short session on aptitude, and today what we're going to be working on is counting the total number of cubes or blocks in a given figure. So you will have a figure given to you which has a multiple number of blocks in it, and we have to find the total number of them. Let me pull up the PDF. Okay, so before that I'll just show you the main basic part of it. So you see in this, what you have is these are the 3D based questions, which means that they'll be testing your mind or brain to be able to calculate things in 3 dimensions at the same time and be able to visualize things in this sort of fashion. So the goal over here is simply you are given a figure which can be symmetric or non-symmetric, and what you have to do is tell what is the total number of individual cubes in that given figure. So that's the basic logic behind this thing. So the things that you can keep in mind is, in case if you find an object that can be split up into multiple similar looking objects, in that case it's better to do that and then go ahead, multiply those by the total number of them, and then don't forget to add the center one, which is going to have 1, 2, 3, 4 blocks in the center. So coming to that, let's go to the practice problem. So this is problem number 1. So it'll be better if you can get a pen and paper so that you can actually go ahead and check out what is happening here. So if you see here, what you can do is you can even break this into a rectangle. So if maybe I'll just crop this out. Crop this. Oh, not here. Crop this. Why does this not want to crop? Okay, there we go. Finally, go here. Should show up right here. Finally there. I think my PC is slightly low due to the low battery right now. Since there was no power, it's kind of got low. Okay, but no issues. So what you can do is you can figure out certain well-known sort of shapes, such as this rectangle over here. So you can take this rectangle into account, and then if that rectangle is taken into account, you can even take this rectangle into account. You can then take this rectangle into account separately, and then you only have to add the ones in the middle, and which are these two guys, and then just these on top. So you can break the problem down into smaller chunks like this to speed up the workflow, and at the same time it makes it much easier to understand what exactly is happening in the given figure. So for now, I'll just give you guys time to work on this one. Have any of you found the total number of blocks in this segment at least? In this one, right? Okay, so then now you can proceed to the other one. So this is there, then you have this over here. Don't forget the 2 in the middle, because these are not touching each other, and then just this simple line at the top. So what I can do is maybe even switch this into a paint, and then we can keep note of them. So if I go here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this 10 go in for a depth of 1, 2, 3, 4, 5. So that's going to be 5 into 10. $50. And that 50 is again 2 times, because you have it here and you have it here, so that's 100. That's into 2, 100, and then we only have to figure out the rest. So this is how many? 1, 2, 3, 4. 1, 2, 3, 4, 5. So that separate part, I'll do it in red. Let's do 5 into 4 equal to 20. So this is 20, these two are 100. Here we have 2 in the middle, and that 2 is going for a length of 5. So we have, again, let's do it in green, maybe 2 into 5, 10. Finally, in orange, we'll be working on these guys. It's 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So that's 5 plus 5, 10 plus 4, 14. So finally we have 14 from the top. Then I'll just call these leg blocks, maybe. Then the 5 by 4 into 20 is the side one. Side as in this side part. And then that is, the green is just the middle part. Okay, so this is basically the stuff that you're working at, and then you finally have to just add all of these. So 100 plus 20, that's 120, 130, and go here, all of this stuff. Let's just check if you have missed any blocks. 1, 2, 3, 4, 5 by 1, 2, 3, 4. That's 5 by 4, 20. Then here we have 2. Oh, wait a second. So we only said 5 into 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 times. That's 50.
Yeah, I missed 16 somewhere. 16, I think.
No, I think I missed 10 somewhere. So let me check what is. So this is 50. This one is 50. What's the top total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's correct. And the 2 in the middle is going to be 2 into 5. So that's 10. So where are we missing 10 of them? Do you guys see where we're missing 10? Let me check the answer. I think it says 154. What are you guys getting? Are you getting a similar answer or a different answer?
I'm getting 154.
Okay, so these two were like 100, right? The main blocks, which is like this rectangle and this rectangle together. So what did you use to get 154? Because I'm missing 10 somewhere.
Actually, in the middle, that 14 which you said, it's actually 28, right? Sorry, two side, like 2 rows are there. It's not just 14. Sorry, I mean 2 5 are 10. You told,
oh,
right?
wait. In the middle, we are missing this back, the back of this one.
Yeah. That's 2
So
5 are 10. So behind also it's coming.
So it's in the middle that we have messed up over here. So this is going to be plus 10. And then we get the total of 154. So let me just show everyone where exactly are those hidden 10. come on. Okay, so we only consider these two all the way down, but below these guys, which is below these two, there's also another full row. So below these two which are marked on top, there's another full row all the way down. So that is what we have to also count, which is what we didn't do. So that puts us at a total of 1, 2, like this is 1, this is 2, under this one is 3, under this one is 4, and all of these 4 get multiplied all the way down by 5. So that gives us the 20 of the middle joining part, and then the top part comes as it is. So that gives us what we need. So 154, that's correct. Now we can go to the next one. Let me clear this out. Problem 2. Okay, so in this one, if suppose sometimes you have this kind of an additional extra material and you can see a generic shape, like you can see a cube over here, then you can just calculate what is this extra material on each side and then just multiply that by 4 and add it to the total number of cubes in this central square shape all the way to the bottom. So in this case, we can't consider this whole thing because this whole thing is also shared by this one. So we'll have to consider only this much, which is these 6 at the bottom all the way, and the rest all the way to the top 4 times, and then add these 4 additional corner pieces, and then add the central main block. So what's the total height of this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 9 are here. We have 6 here at the bottom. So we have 6 at the bottom. Let's take a pen. 6 at the bottom plus the remaining 8 over here. So 6 at the bottom plus the remaining 8 gets multiplied 4 times. So this is the one which is on each side. Then we'll put corner pieces. So corner pieces are these guys, because if you see, only this part is taken into account because this one is shared between both. So this one will keep out separately. So 1, 2, 3, 4 corner pieces will be there. And then only the remaining part is this, which is a 9 by 9, or basically a 3 by 3 cube, which gives us 9 cubes per floor, and then we have a total of 9 floors. So let me call it center. That's 9 by, let's confirm that, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 by 9, that's 81. That's equal to 4. Then 6 plus 8 is going to be 14. So let me just pull up a calculator so that we don't make any mistakes. So 6 plus 4, 6 plus 8 into 4. 56 plus 4, that's 60, plus the 81, which is 141, which is the correct answer. So get all of this stuff. Oh, this was 91, 60 plus 81. Okay, so this was 56 then. Yeah. So 56, and then we add all of this stuff together. Gives us 141. So are you guys getting the same answer? Amston?
No, I'm not getting it.
Okay, so let's break down each one then. So let's first just focus on this one because this is the most easiest one, which is the central segment. So let me go ahead and screenshot this to show you that. And let's go here. Okay, so we're just thinking about this central segment right here. So forget everything else. Let me make this slightly bigger. So how many blocks do you see inside the red shape? That's going to be 9.
9.
And how many floors do we have in total? So how many floors do you have from top to the bottom? So if you're getting slightly confused and counting over here, it's better if you count right here because you can see the edge. So you have 1, 2, 3, 4, 5, 6, 7, 8, and then below the back of this cube, there's one more which is keeping the 8 up in the air. So that's going to be the 9th one down there. So you have 9 per floor and a total of 9 floors. So that gives you the 9 into 9, which is 81. So till here, are you good?
Yes.
Okay, so that gives us this 9 by 9 into 8 is equal to 81. Now the next, let's come to this part. So if you see the figure, there's one thing that is repeating 4 times on each side. That is this extra segment right here. So if this is my 9 by 9 cube, that same cube comes over here till here. So what is extra is this part, these 6 over here, because this cube is resting on one cube. So that is also considered right there. So that's why you have, this is the number 1, 2, 3, 4. This one at the back is 5. And what this cube is resting on is number 6. We'll make this just a little smaller. So what that is resting on is number 6. So these 6 are at the bottom. Till here, are you good?
Yes, yes.
Okay. And then the total is 9. But the bottom layer we are not counting because you've already taken it into account over here. So how many are left in this vertical column that you have right here?
8.
Okay, so that's exactly what we are adding over here, which is the 8, which is in the column, plus the base, which is 6. So that gives me this whole segment right here, plus the column. This whole thing is being repeated 4 times. If you see here, this is the 6 and the 8. Here, this is the 6 and the 8. And that side also same thing, and the other side also same thing, which is why the top looks completely symmetric, as if it's repeating on all sides the same. So this is one more thing that they haven't shown you exactly what's happening on the other sides, but since they've given you enough data over here of what is happening on this side and the top looks the same, it automatically means that the same thing is happening on the other side as well. So now you have 6 plus 8 over here, 6 plus 8 over here, 6 plus 8 over here, and 6 plus 8 over on this side where my mouse is right now, and that's why you multiply it by 4. But if you see, when we add all of this, we are leaving out this corner piece right here, and the one which is at the back over there, and that is why we add the 4 corner pieces back into the calculation. And then when you add all of it, you get 141. So are all of the 3 stages clear now?
Yes, 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 sir.
And you're getting 141, right? I'll give you a little bit of time to calculate that. Okay, you got it. Fine. Then we can proceed. Yeah. So anyone else have any issues with this specific on how to dissect this into the component pieces? If not, we can go to the next one, which is number 3. Okay. So number 3 is what we are working on. Someone just wants to join in. 1 second. So with number 3, again, if you want me to show you the segments, it's mainly going to be horizontal flows as individual segments, because nothing is the same. So only if it's the same, we can call it as a given segment and multiply. But otherwise, let this thing load in here. So we'll have to consider the bottom entire thing as one floor and one segment. Over that, we'll add the next floor as a separate segment. So we can just multiply side into side to get that total. Over that, we'll add this small one as another segment. So you have the first floor, second floor, third floor as just side into side multiplications. And over that, we can then just have the total of this stack, which is 1, 2, 3, 4 of these 4 times. So just 4 into 4, 16. So that's how we can work out this one. So I'll wait for the answer. And in the meantime, we can.
99.
99 is correct. So 144, the person who said 144, what was your logic of going about? Let's see where you went wrong. If not, we can also solve it out.
Actually, that corner box I took double.
Okay. So here it's going to be 1, 2, 3, 4, 5, 6, 7. 7. I'll just call this base first. I'll call this base 1. B1 is base 1. I'll just call this G for ground. First, second, ground, first, second, and then the pillar, I'll call this. So the pillars are 1, 2, 3, 4 per stack, and total 4 of the pillars are there. So 4 into 4. 16. The second one, which is this one, is total of 1, 2, 3 by 3. So 3 by 3. That's going to be 3 by 3. 9. And then the first one, which is this block, is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 5 into 5. That's going to be 25. And then let's just do the final one with, we got a message. So Jishnu, you want to say something? Jishnu?
Actually, that figure, it's having bottom base also, right? Or are we considering only one layer?
So we are considering the entire base, right? So this entire thing is being considered, and I'm multiplying this by this whole number. So all of the bottom is going to be solid.
Yeah, that I got, but still I'm asking, the second layer is there on the ground one, so it will be having the same layer below.
Yeah, this will have the same thing below it.
So it will be double, right?
But I'm counting the ones at the bottom when I'm counting this layer.
Okay.
So I'm splitting up into, like, each floor I'm splitting up into one, because otherwise it will be slightly more complicated to, to count all of these guys. So if I can just simply multiply square into square, I can get this whole thing, I can get this whole thing, and I can get these three, like ground, first and second floor, by just multiplying the side into side and then add the pillars on top.
Yeah, got it. I just confused. I am adding the layer.
Okay. Because in this case, counting all the way to the back, you might make a mistake because they're not seen over here. But in the previous question, all of them were seen at the top, then it becomes much easier. So if it's not seen, then just the multiplication of side into side is safer.
Yeah.
If possible.
Yeah.
So what are we left with? We are left with the ground, which is going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so 7 to 7, 49. So this puts us at 49 plus 25 plus 9 plus 16 gives us total of 99. So this is how you can split this up easily. One more way how Jishnu was speaking about was he was splitting up this inner part, this second flow, for 2 flows. So he was going here and the one below that, and then counting these as individual ones for the ground flow. But the problem with this is he can't see at the back what's happening, so there's a chance of making an error. So due to that, it would be better to consider each flow as a separate segment. So you can simply multiply the side into side, the total number of cubes, and that will give you the total cubes for that entire floor in one shot. Okay, let's go to the next one. Any issues on the question number 3? If not, we can proceed to the next one. Looks like no issues. So this is extremely where the power of multiplying by 4, if you find some kind of symmetry, will come and help you. You don't have to do the same thing multiple times. So from this figure, what exactly is the shape that is being repeated on all 4 sides? So the shape that's being repeated, if anyone can speak up.
6 cubes. 6 cubes are repeated, I guess. Not 6.
So
7 cubes.
So let's count and see. So we have 1, 2, 3 here, 4, 5, 6, because this cube is resting on something. So 6 are over just here. Then we have 7. So we have 8, we have 9, and this cube is resting on something. So total of 10, I think, are being repeated 4 times. Because we have this cube which is resting on something. So that's 1 and 2, 3, 4. This cube is resting on something. So that's 5, 6, 7, 8, 9, 10. So I'm getting 10 actually. So have a look if you're also getting the 10. Or maybe I'll just go ahead and draw out how we are getting 10. Because this is the main thing, that you should not get the number of cubes that are being repeated incorrect, because otherwise your multiplication will go wrong for the symmetry. Let this load in. Okay, so what we have here is, let me make the pen slightly smaller, maybe red. So we have 1, 2, 3. So this cube is resting on a cube at the bottom. It's not floating in midair. So that cube which is at the bottom is number 4, then number 5, number 6. Here we have number 7, we have number 8. This cube is resting on a cube, sort of, on what it is kept over. So that cube at the bottom is number 9, and then this cube at the top is number 10. So are you getting this? So 9 and 10 are the cubes on which 5 and 10 are kept over. And if you see, this entire pattern is being repeated everywhere else. That same thing is over here. The reason why we're not counting this side things is because they are shared by both of them. So we'll just add this later as a corner piece. So this will be the corner piece, corner piece, corner piece, and corner piece on that for that last side at the back. So 4 corner pieces are there. Let's make a note of that. Corner 4. Then I'll just call this the repeat, which means what is repeating. So repeat is equal to 10 into 4, 40. And then what else do we have? We have problem number 4. Let's zoom in a bit. So this is done. This is what is repeating on all 4 sides. You've added the corner pieces. Now the only thing left is the center, which is 1, 2, these two blocks are sitting on 2 blocks high from the ground. So those two in the middle, which are hidden right now. So this is 1, 2. This one is sitting on number 3, and number 3 is sitting on number 4. So 4 we have in the center. So center equals 4. So if we add this, how much do we get? 48. Let me know if you guys have any issues with this, because there were some issues with identifying the total number of repeat blocks. 1 second, someone wants to join in. So here, let me just explain this. The corner ones is what we have kept separately because this corner block is being shared by both of them. So we keep this separate as a corner block. But what is being repeated is this block, the block which is under this, then this one, the block which is under this block, these two over here, and these 3 over here. So that's 3 plus these 2, 5, plus the one which is under this, that's 6, 7, 8, 9, and this block is under one more, which is 10. So 10 on each side is being repeated, plus we have 4 of the corner pieces, and then we don't count these blocks because you see these blocks are part of the repeat. So we have the 40 in the repeat, the 4 corner blocks, and then the center we have 4 standing vertical, which is what we added as a center 4, which gives us 48. So anyone is getting any other answer or any issues? Do you want me to explain any of the segments again? If not, we can go to the next one. Maybe I'll just give you some time to go through.
Move on, AVITO.
Okay, we can go on. Okay. So where's number 5? Okay, so this is number 5. So immediately I see number 5 has some issues over here. You see this additional gap. So there's a couple of issues in this model or this image. So maybe we'll come back to this at a later point of time because these issues might confuse some people thinking that these blocks are floating in midair. So for those reasons, just not to confuse you right now, we'll come back to this one at a later point of time. And we'll go for number 6, which looks like a pretty easy one. So I'll leave this one to you guys. So before we start with the final answer, let me know how you guys are going to be dividing this into segments.
Bottom 2 rows are there.
Okay.
So it will be 64 into 2, 128.
Okay.
Then one row is there.
Just add the top in. Okay. So your final answer is
150. 1 second. 120. 164.
164. Because you said the bottom is 128. So how are you getting 40 more?
Not 40 actually, 36.
So you're saying final answer 136?
1 second. No, sorry.
So 128 is at the bottom. That's done. So how many at the top? And then you have to add those two in. The thing you have to keep in mind is that here you have a hollow thing, so some of them will become less as well.
Is that 128?
128 final answer, or just the bottom part? because here if you see, this center part is hollowed out. So you have 1, 2, 3, 4. 4 by 4, one of the cubes is hollowed out. So you have to take that into account. So let me just show you how you can get this done. So again, if you're calculating the total bottom instantly, it's going to be 8 by 8. So that's 64. 2 times, so that's 128. Let's call this base. 64 into 2, which is equal to 128. Then we have a hollow because some part of the middle is removed. So if you see right here, this total is 3 blocks, but here I can only see 2 blocks. So if I was seeing over here also only 1, that means both the bases were complete. But if I can see 2 over here, that means this top one over here, which is there, that is being made into a small cutout over here of 4 by 4. So hollow is 4 by 4, which is equal to 16, which is this cutout right here. Because if you see here, I've only kept 1 block extra, but here I can see inside 2, which means there's a small cutout over there of 4 by 4. And then finally we just add the top part. So the top part is how much? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So I think this is going to be 20. And then we can just simply add this up. This is going to be 36. Oh, so these are minus. One more thing that I forgot to keep in mind is this has to be a minus because these are removed. So this will have to be a minus sign. So plus 20 minus 16, total is 4. Because these are the missing ones that we have calculated. So 4 plus the 28 or the 128, which is 132. Final answer. Any issues with the hollow part? Because if you see here,
much better. Yeah.
Well, what's that?
Subtracting one, otherwise it becomes very difficult.
Yeah, so that's why you can first go ahead and multiply your base as it is, because you're getting your good square shape, so you can easily multiply your 8 by 8. But then here you need to pay attention that here you're keeping a block and you're only having a space of 1. But inside when you look, you're having a space of 2. So that should give you a hint that some part is being made into a pit over here or is being cut out. And that is what we need to keep a minus sign over here, right here, minus sign. And once that minus sign is there, then you can add all of the things up and you get 132. So I just simplified minus 16 plus 20 to give me plus 4. And I added this with 128 to get 132. So any issues with this or anything else that you want to add on, or any other approach that you used? Anyone has any other issues with this one? Number 6?
No, move on.
Okay. So number 7. Yeah, so number 7, I'll give you guys some time to work on this one. Find out if it is symmetric in any fashion. And if it is symmetric, then you can simply do one half of it and multiply the other side. So I'll give you about 30 seconds for this one. Excuse me.
106.
How much?
106.
106. Okay, let's wait for someone else. In the meantime, maybe you can tell us how did you segment this so that you can speed up your workflow instead of counting each and every single block in the image.
Yeah, 106.
So the PDF is showing 100, so we'll have to verify this. So let's have a look at it.
It's 100.
Yeah. Let me clean this up.
It's going in increasing order. Just we can multiply it. 100.
Exactly. So you have identified a pattern to speed up your work. So if we ignore, we can ignore this middle part for now. That gives us two identical parts on both sides, first of all. So we have this part and this part, which is exactly the same. So if we can figure out one part, we can then multiply that by 2 and add the middle part inside. So for now, let's just work on this part. We're just focusing on this. So here we see we have 2 blocks. Then it goes into 3 blocks. Then it goes into 4 blocks, 5 blocks, and 6 blocks. But here if you see, we have only one of the 2. 3 is there, 2 blocks are there of 3. Then we have, there's 2 blocks of 3 each. Then here we have 3 columns of 4 each. Here we have 2 columns of 5 each. And here we have 1 column of 6. So we can simply multiply to get the total number on this side. So we have 2 plus 2 into 3, which is going to be 6. So we have that 6 plus this 2, 8. And then let's just use a calculator to keep track of everything. And also you can see how things are being added. Wait, this thing has come too big. Can I just make this simple? Okay, this is the minimum. Can I squeeze this in? Yeah, this is better. So this is this 2 at the bottom plus 3 over here and 3 over here because we have 2 of those. So that's 6 plus 6 plus here we have 4 and we have 3 of them. So 4 into 3, that's going to be 12. Here we have 5 and we have 2. So 5 2s are 10 plus 6 only at the top. So that's 36. Now we have totaled up 36 as this entire side. So this entire side also is going to be 36 only. So 36 multiplied by 2 is what we get. So let me write it down. Side A, I'll just call it sides, is going to be 36 into 2, which is equal to 72. And then we need to add in now, or we can do a separate calculation. Let's call this middle. Let's move all of these lines out. Why is this giving me this? I want to use the pen. This thing got stuck or what? Let me just re-click that. That thing got stuck for some reason. I don't know why my system is so laggy today. I think because of that power, my battery is still charged up or something. It wasn't this way last time. Yeah, so we have calculated what is there on both the sides. Now we just need to calculate the thing in the middle. So this is 1, 2, 3, 4, 5, 6, 7. So this is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Here what can help you is if you memorize the formula for the series of natural numbers, but that formula might simply confuse you, etc. But if you're planning on learning it anyways, that will be great. Otherwise you can simply go ahead and add as well. So this is to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. That gives us again 28. Then we add the total. We get the value of 100. So any issues with this? How we calculated the sides? For the sides, we simply went with a easy approach, which is here we have 2 of them. So this is 2. Here we have 3, then 4. But here we have 2 columns of 3. Then here we have 3 columns of 4. Again 2 columns of 5 and 1 column of 6. So we just multiplied each of those numbers separately, added the total to get this entire side as a whole, then multiplied by 2 to get on the other side as well, because we can see it's exactly the same thing, and then just add the blocks which are in the middle and you get the final answer. So this is how you can segment it and work things out. Otherwise, if you look at it from a perspective,
directly we can do
the whole thing.
Yeah, like see,
yeah,
first
okay,
is 1, then 2 into 3. Sorry, yeah, 2 into 3.
Got
then
it.
3 into 4, like
3 into 5, right?
3 into 5, yeah, 3 into 5, like that directly one row. If we see, it will be
sure. Let me show that method as well, or that approach.
But that complicates the calculation a little bit. This is simpler, I guess.
Yeah, so I think because mainly the into 2 is there, right? So that makes it slightly simpler. But otherwise, if someone would just like to learn how another way that this can be done is, what he's saying is this is one block. So 1 and only one of it is there. Here you have 2 blocks and you have 3 of them. So you'll have to do 2 into 3. Here you have 3 blocks. Let me do a different color. Let's do yellow. Here you have 3 blocks and you have 5 of them. So you'll get 3 into 5. Then you have here 4 blocks and you have 1, 2, 3, 4, 5, 6, 7 of them. So 4 into 7 you'll have to do. Then you'll have to do 5 blocks into 1, 2, 3, 4, 5, 5 into 5. And then finally back again 6 blocks into 3. And then this might be too light. Let me go back to purple. 7 into 1. So you'll have to add all of these things. So 7 multiplications and add all of those out. So 1 into 1 and then 17 into 1, 6 into 3, 5 into 5, 4 into 7. And this will also give you the same answer. So you can choose whichever approach you prefer. Usually for me, if I see that there is some kind of symmetry, I prefer to do the multiplied by 2. But in this case, you can also prefer this method if that works better for you. So 100 is the correct answer. Any issues by anyone? If not, we can proceed to the next one. Let me see if anyone else is there to be added. No one is there. So Amston, all good?
Yes. Good.
What about Salman? Are you active?
Yes. Next one.
Okay. So we're proceeding to question number 8. Here we go. So in this case, you have to keep in mind that this white gap over here that you see, those are missing blocks right here. So these are all missing blocks, and also missing blocks over there is what you have to automatically understand.
Is it 31?
So this was question number 8. So 31 is incorrect. We'll have to verify that.
48.
48 is also incorrect. So let's just think about how will you segment this, because we have these hollow gaps over here. So what I would prefer is, let me consider this entire middle part to be hollow and then add all of this material back inside. So what is my outer total number of blocks? So this is my simple side into side that I'm going to multiply, and then I'm going to subtract what is the hollow part, which is this whole section over here.
Is it 53?
53 is close but not correct.
52.
52 is the correct answer. So let's see if we can get that from understanding the segmenting of this problem.
Yeah,
So
52.
So here 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7. So 7 by 7 is our base. So that gives us 49 as the base layer full. Let's just call this base equal to 7 by 7, which is equal to 49. Then hollow, because the base is chopped up in these locations marked in red. This one is, at the back, same thing is happening on all 4 sides. So we can either calculate what is the total number of blocks that are missing and then multiply that by 4, or we can even just go ahead and make this entire thing hollow as well. So I'll go with this approach of making this entire thing hollow so that I can just simply add whatever is remaining after the fact. So what is the total number of blocks that are hollow is 1, 2, 3, 4, 5. So it's a 5 by 5 hollow. Keep the hollow in red maybe. And again, since it's a hollow, you have to keep in mind it has to be a minus sign before the value. Minus 25. Then I'm going to call these small pieces over here as corner pieces or joining pieces. Let's just call them joining pieces. So you'll have 4 joining pieces. So I'll just call this as join. So we have 4 of those. Then we have this center block. So the center block is a total of, let's just get rid of those. So we have 1, 2, 3, 4, 5, 6, and this is basically 3 deep. So 6 threes are 18. So we have 6 into 3. Another way you could do this, you could say each one of these layers is basically 9. So 9 plus 9 is also 18. That's another way you could do it. And then finally we have the top, which is 1, 2, 3, 4. And then this is 5. And this 5 is sitting on one more. So that is 6. So we have 1, 2, 3, 4 on the sides. Then this block over here, the topmost block is number 5, and number 5 block is sitting on one more block. So that block which is hidden now, which we can't see, is the 6th one, which is over here. So if I just mark it over here for better visualization, 1, 2, 3, 4, this 5 block is over here, and this 5 block is sitting on one block. That is number 6 over there, which is hidden. So 6 over there. Let's add it up and check. So we have 6 plus 18, that's 24, plus 4 again, plus the minus 25, so minus 25, and then we add the 49 plus 49, gives us 52, perfect answer. So that's how you can segment this with the base, then hollow, then the joining pieces, the center block, and the top piece which is there. So this one is also solved. Let me clear this out. and we can proceed to the next one. So question number 9. Looks like we have a question. 1 second. Okay, we can move on. Great. So question number 9 looks like an easy one because you have the same pattern carrying all the way through. And again, 2 ways that you can get this thing done. So I'll give you 30 seconds and then I'll explain both methods that work for such figures. And then you can prefer whichever one you feel is much more easier for you to memorize as well. "30 seconds time."
$126.
126 is correct. So last 10 seconds for this problem.
126.
Yeah, same.
Okay, so what
126.
method did you guys follow to segment this? Do you just go ahead and count all of these and then multiply inside?
So I counted, see, there are 1, 2, 3, 4, 5, 6. So 6, this is 6 is fixed
Yeah,
number of this thing.
the depth
Then
basically, right?
yeah, the depth. Yeah,
Okay.
the depth. And then just multiply with number of steps are decreasing. So 1 plus 2 plus 3 plus 6 into 1 plus 2 plus 3 plus 4 plus 5 plus 6.
Okay, so your method was you have 6, then you have 5, 4, 3, 2, 1. So open brackets,
Yes.
6 plus 5 plus 4 plus 3 plus 2 plus 1, close brackets, multiplied by 6, the whole thing.
Yes.
Great. Another approach which some people prefer to take is they prefer to just multiply the entire over here this way. So they'll go 1, 2, 3, 4, 5, 6 this way, multiply by 6. So 6 plus 6, 36 over here, then 6 plus 5, then 64. They prefer to add. If they don't want to do this large sort of, big bracket to multiply, then they can do each one of these layers as well. So 6 into 5, 6 into 4, or 6 into 6, 6 into 5, 6 into 4, 6 into 3, 6 into 2, 6 into 1. Manually, and then add them up, or as you said, you can just do one massive bracket, put it into a calculator and get this done. So this will be pretty simple one, which is going to be a 6 in the outside multiplied by 6 plus 5 plus 4 plus 3 plus 2 plus 1, and then you can just simplify this. So here if you check, you have 10, and then this will be another 10, that's 21. So 21 into 6, and then you can simply put the 6 here, that's 6, and this is 12. So 126, pretty quick. Great, so let's move on to question number 10. I don't think anyone will have issues with that. Question number 10. So this one you can segment with some symmetry. So if that helps you, you can use that because it will help you save some time. And again, this one has a constant number of blocks in terms of the height. So this makes it very easy to find the correct answer.
$81.
81 is correct. Give the others another 15 seconds on this one.
$81.
81, right? Okay. So everyone's getting it. Basically, how you can get this done is you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 are also there on this side. So that is what gives you the 10 plus 10, which is 20. And then you can add this middle part, which is 1, 2, 3, 4, 5, 6, 7. So you'll get 27 here and 20 on both sides. I mean, no, wait. did I say 20? This was 1, 2, 3, 4, 5, 6. Oh, so 7 in the middle and 20 on both sides. So total 27. 27 multiplied by 3. So which is what gives us a total of, if I just write it down for those watching the recording in case they don't get it. So the sides are equal to 10 and sides are multiplying by 2 because left side plus the right side, and center is 7. But this is all for one floor. So we have 3 floors, so we have to do 27 into 3, which is equal to 81. That clears this one out. Let me go to question number 11. Okay. So again, this one has some missing blocks, and that's why we see this slight weird gap over here. So you'll have to keep that in mind. Also, one more thing to note is this time this gap is not there on the other side, and that is seen because here you can see only 2 blocks, but here the gap is there after 2 have completed. So this is the third one that is missing, but here there's only 1 block, and then the second one it starts the main geometry, so it's not symmetric in that way as well. So this is question number 11. Let me go ahead and prepare this one for showing the segmentation that can be done. Yeah, so waiting for another 15 seconds. Okay, so I'll just explain the segmentation that can be done, which is this is a square, so you have this by this. Let's see if it's a square. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. So this is a 7 by 7 square, but we have this gap hollowed out. So the hollowed out gap is total of, this is too light. So this hollowed out is a total of 1, 2, 3, 4, 5, and 5 of only one row. So that's 5 into 1, so 5. So 5 are hollowed out, and 7 by 7, this is all of your first bottom layer. Let me make note of that. So we have the base, equal to 7 by 7, but the hollow is equal to minus 5. So hollow always comes with a minus sign, keep that in mind. Once this is done, then we can go to the second layer now. On the second layer, we see that we have 1, 2, 3, 4, because we can take this entire thing and club it over here. Imagine it is as if it's just stuck over there, because it's the same number of blocks. Oh wait, it's not the same number of blocks. We have this, yeah, it's the same number of blocks, because these we are considering extra on top. So 1, 2, 3, 4, 5, and this is 1, 2, 3, 4. So we can say the second is first floor, because this is the base. So over the base is the first layer, which is going to be 5 into 4, right? 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 into 4, 20. And then your top layer, which is just these guys, 1, 2, 3, 4. So I'll just call them top pieces. Those are just 4 pieces. So we need to add all of these values, which is going to be 49 plus, so 20, and this minus 5 plus 4 gives us minus 1, so that's again 19. But just for the people at home, I'll just add all of them individually. So plus 20 minus 5 plus 4, which gives us the final answer of 68. Any doubts on this one? How we did the hollow, the first floor, how we clubbed them together. So what we did is, since these blocks and these blocks are exactly the same, we just made these guys to touch that so that we can simply multiply the 1, 2, 3, 4 by 5. And then we just added these top blocks at the end. So 68, question number 11. Looks like you guys also got the answer, so no issues. We can move to question number 12. So looks like what we'll have to do is do maybe 14 or 15 today. Yeah, so 15 is the total number that we have, so let's finish 15. So now we're currently on number 12. Last 15 seconds for this one. Question number 12. So in terms of the segmentation, we have the base, which is a double base because exactly the same. Then you have the hollow part over here, hollow part, and over here as well. And once this is done, then you just have that pyramid structure at the back. So let me go ahead and write down the base, the hollow, and after that we have, this is the base, that's the hollow. So then this becomes first layer, second layer, third layer, fourth. So first, second, third, fourth. Let me go back to this, and then we have first, second, third, fourth layers over the base. So what's our base? 1, 2, 3, 4, 5, 6, 7. So 8 by 8 base. $64 there. What about the hollow? The hollow is, looks like, so here one thing you can do is, look at this block right here. I can simply push this block up. That will complete this also for me. Because right now this is actually a perfect sort of square floor, apart missing this block. And this is also a perfectly nice hollow. Only thing, this block is extra over here, so I can just assume this block to be pushed upwards. So now I have this first layer as completed and this hollow also as completely open. So this hollow now becomes in the middle over here 4 after moving this block to the top, as well as we need to count these guys. So hopefully you guys understood this part, which what I'm doing is so that I can complete this layer perfectly and compensate for this missing block over there. I am pushing this block as if it is over here, and this also clears for me this hollow piece completely. So that's 4 over here hollow, and so I'll just write it over here, 4 hollowed out. And here we have 1 2 3 4 5 6 7 8 9 10 11 12. So I think we have 12 blocks missing over here. Can you guys confirm that? So 1 2 3 4 5 6 1 2 3 4 5 6 7. Oh, there's one more block here which I forgot, which is touching this one. So this is not 7. We forgot about this block right here. This guy has 7 over here. Then this is 8 9 10 11. Then this block will have 1 over here, which is 12. Then this is 13 and this is 14. So 14 are there in the hollow. Minus 14. So now that we have cleared the hollow part as well as pushed that block up, we get a completed, one second, we get a completed first layer, which is this guy. So this is just 1 2 3 4 by 4. So 4 by 4, that's 16. Why is this pen not working? Oh, okay, then finally it showed up all of them at the same time. So 16. Second one is above that is going to be 3 by 3, that's 9. That's 9. Above that we have a 2 by 2, that's 4, and 1 on top. So if we add all of this, what do we get? 64 plus 14. Pull up the calculator. 64. Oh, not plus, minus. Remember this minus sign. Minus 14 plus 16 plus 9 plus 4 plus 1. So total of 80, but we have 81. So where am I missing? One of them is what I need to check. This one has
missed the hollow one, 4. The cube that you took it, the one which you took it up in the middle.
I added that over here, right? In the hollow. Oh, 14 plus
4.
Plus 4 here. Because these are 14 over there and these 4 over here. So that's what I missed out. So this plus 4 is going to be over here. So it's actually 14 minus 14 minus 4. Now how much do we get? And what about these guys? Are these guys good? 1 2 3 4 by 1 2 3 4. That's 16. This is 9 4 and then 1 at the top. So those values are correct. 16 9 4 and 1. And then the base is going to be the oh, we also have a double base, which is one more thing I think I didn't take into account. So the double base is going to be 8 into 8, 64 into 2, because you have 2 layers of the double base. So we have this multiplied by 2, and this again, as you mentioned, is minus 14 and the 4 additional hollows which are there. So I put both of them inside the minus sign, so it becomes minus 14 minus 4. So now I get 128 minus 14 minus 4 plus 16 plus 9 plus 4 plus 1. Oh, wait, 140? How much is our base? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 3, 4, 5, 6, 7, 8. So 8 by 8 is 64. Then we have 2 of those and only one of them is cut out, because we see only one block over here. This is 128. Then we have the hollow part. Did I get the hollow thing in? So 128 minus 18. And all of these would be...
The hollow ones are not 14. They should be 13.
13?
Yeah.
No, but I'm considering this one goes up.
That one. This outer one.
Oh, no. 15.
15?
Outer one.
Here, this one? Or are you talking about this one over here?
Outer one.
This one here?
Yeah. This hollow region. This should be 13 and not 14.
Let's just check it out.
That we counted twice. That is why it is coming to 14.
So these are 2 over here,
one.
okay? These are 2.
Yes.
And 2 over here. So that's 4. Then here we have 1, 2, 3, 4. And here we have 1, 2, 3, 4. And then we are left with this block over here. So how much does this give us? So this is 4 plus 4. That's 8. These two are plus another 4. That's 12. And then there's only one left. That is 13. Okay, so that's 13 then over here. So this hollow guy is 13. This block goes up, so this is 4 over here. That's at least correct, right? So we have a total of 13 and 4. Let me check that out. Eraser. So we have minus 13 and minus 4 as well for the hollow ones, which is total hollows are minus 17. So you're getting this as a total hollows minus 17.
Yes.
Okay, and this is finally there. And now we can start adding the correct values. So 128 plus minus 17 plus 16 plus 9 plus 4 plus 1, 141. So then we get the correct answer. So somehow I had additionally counted one more on the outer hollow region. But then once we broke down that hollow region into additional components, we saw that there was actually only 13 of them. So great catch on that. Now we can go to question.
Actually, earlier we counted it from the outside. That is why we did the mistake. Counting it from the inside. This time you did that was better to do.
Yeah. And we also put proper barricades, like once whatever we have counted. So now question number 13. Let me just clear this out. Come on, clear. Right click on select. Okay, by the time this clears, let's just keep the 20 seconds or the 25 seconds for you guys to solve this. So this time if you see, it looks rectangular, which means this will not be a square. So that is one thing you'll have to pay attention of.
296.
Just 96? That's incorrect. So
296.
Yeah, 296 is correct. So if you see here, what we can do is instead of just taking this much and going all the way down, then we have this hollowness to count for each and every single layer. So what is better is if we just count layer by layer as per whenever there's a change. So here if you see, this is the bottom one is 1 2 3 4 5 6 7 8 9 by 8, I think. 1 2 3 4 5 6 7 8. So 9 by 8 3 times. So base is 9 by 8 3. Then we have this layer, which is this one, which is 1 2 3 4 5 6 7 by 1 2 3 4 5 6. So 7 by 6, first layer, because the base is at the bottom. So the first layer above the base is what I'm writing over here. 7 by 6 is equal to then here we have 1 2 3 4 5 by 4, second one, second, five by 4, and then finally this block at the top, which is 1 2 3 4 5 6 7 8 9 2 times. So that's 18 at the top. This will be 20. This will be 1 second. Why is this pen giving me a weird color?
First one is 216.
What's that? Yeah, the answer is
216. 9 into 8 into 3.
216. Okay.
Answer is 296.
Yeah. So this answer you're saying, right? 9 into 8 to 3, 216. And then we have 6, 6 to 36, 6 sevens are 42. So let's put this here, 9 into 8 into 3, which is 216 plus 42 plus 20 plus 18, which gives us 296, final answer. 296 for question number 13. Now we go to question number 14. Let me zoom in a bit. And again, this is now a question on symmetry. So you'll have to find out what exactly is being sort of repeated. And once that is identified, then you can simply multiply by 2. But in this case, the symmetry part also is slightly big. So you'll have to find out if you can simplify the symmetry part to easily segment the one symmetry parts on one side. So calculate that and then multiply by that by 2, and then whatever is remaining in the middle can be added on. So 30 seconds starts. Okay, so immediately it's visible that the part that is going to be symmetric is all of this part. So we'll have sides. So how much do we have in the middle? In the middle we have, so this is gone, and at the same time all of this also will be gone. So I'm left with only these things in the middle. So that is going to be, this is at the bottom. Let me zoom in a bit. So we have 1, 2 over which this is 3, 4, and that is going for 2 because this whole thing is at this level, and below that also we have one more. So that is 4 into 2, which is 8, and then 3 on top. Oh, not 3 on top. This guy is sitting on one more, so that is 4 on top. So 4 on top plus the 8. So again, just to reiterate, we have here on top over here, we have this one, 2, 3, and 2 is sitting on one more, which is number 4, which covers these 4 over here. Then you have this main base over here, this one. So over there we have number 1, this one is sitting on number 2, this one is sitting on number 3, and number 4 is there at the back. But this is also at a height of 2 blocks, so we need to multiply these 4 also by 2. So 4 into 2 and the 4 on top, which gives us total of, as written over here, 12. Now it's time to calculate the sides. So while calculating the sides, we have a simple base pattern over here, which is all of these guys. This is your simple pyramid, which is going to be basically 4 into 1, 2, 3, 4 into 1 plus 3 into 2 plus 2 into 3 plus 1 into 4, 1 into 4 plus 1 into 4. So we have this going on. For all of these guys. Then we have this 3 outside over here. At the same time, we have over here total of these guys, which comes to 1. Let me just take a lighter color, maybe like yellow maybe. So this is 1, 2, 3, 4, 5, and 5 is sitting on one more, which is 6. So 6 over there and 3 over here. This is 6 plus 3 plus all of this stuff. So this is basically 4 plus 4, and then this is 6 and 6. So 6 plus 6 will be 12, and the 12 plus the 8, that's 20. So 20 there plus,
It's not 6, it's 9.
which one?
It's 9.
Here
Which you wrote on the pen.
or this one?
4 into 1. Yeah.
Yeah, so 6 plus 3. So total I'm saying 9.
Okay.
Is this what I'm saying?
No, I am talking about the part that you have written. That 4 into 1 plus 3 into 3. 9 plus 2 into 3. 4, 8.
Yeah, so I've just written the final value over here of this entire massive calculation. So the total of this I'm writing over here. So if I put that over here, the side extras are 3 over here, and this is 1, 2, 3, 4, 5, 6, So that's 9. This 9 over here. This much is okay, right? This 9 is fine, right? You understood these 3 and these 6 here.
Yes.
So, and here we have 4 into this, and this. So that gives us 4 plus 6.
4 plus 9, I think. It's 2 there. 3 into 2.
3 into 2. Yeah, 3 into 2. Because see here I have 3. 1, 2, 3. And this is the first one and this is the second one. So 3 into 2.
Okay, got it. Thank you.
I'm counting this way. You got it, right?
Yeah.
And then here I have again 2, which is 1 and 2, 3 times. 1, 2, 3. That goes over here. And then 1 block only, but 4 times. So 1, 2, 3, 4, which goes over here. So we have 4 plus 6 plus 6 plus 4. 20 plus 9. So that's 29. And again, don't forget that this 29 is into 2 because we have 2 of them on both sides. So this whole thing and this whole thing. So this should give us equal to 58 plus 12, 70. So any issues with this now? Let me show you the segmented version. So we have this whole pyramid structure given over here, plus 3 plus 6. So that's 9, 20. So that's 29 on each side. So we get the 29 multiplied by 2 and then what is in the middle, which is already added. That's looking good. So any issues, or we can move to question number 15, the last question for today.
Yeah, we can move ahead.
Okay. Slightly position this. Okay, here we go. Again, if possible, we can use symmetry to try and simplify this one as well, because if you see, it looks symmetric, which means there will be some kind of thing that you can multiply by 4 to simplify your workflow. 30 seconds. Here again, we have sides, we have the middle, and so I'll just call this sides, middle. This is the middle, this is the sides, and corner piece. Let's call this. So if we see the corner, we have just 1, 2, 3, 4, 5 corners. But again, the 5 corners are on 4 times. So 5 into 4, that's 20. Coming to the middle piece, we have 1, 2, 3, 4, 4 by 4, which is 16. But in the middle, 4 are removed. So you can even write it like this, which is 16 minus 4 per height, and the total height is 1, 2, 3, 4 again into 4. That's going to give us basically 12 into 4, that's 48. And the sides are what has to be calculated now. So sides are 1. You can just count over here as well. So 1, 2, 3, 4, 5, 6, 7. And then 7 twos are 14. So 14 into 4. That's going to be 28 plus 28 is that 56. Yep, so that's 56 at the top plus the 48 plus the 20 gives us 124. So let me know if you guys are getting the same answer.
Yes.
Okay. So that's it for the 15 questions. Out of the 15 questions, any one, I think we've kept one missing or something. I don't remember which one though. We'll just come back to it next time or something. So any doubts with the methods that we have discussed? If not, I'll try to summarize all of the logics that we have used. So mainly the first thing will be, if you have a block and it has a hollow piece, what you can do is, if you have it as a square, you can multiply side by side and then just minus the hollow piece out. But if you have some nice symmetry, then it's better to take the symmetry into account, multiply that by 4, and if there's some corner pieces, you can then just add those at a later point of time. One more thing, that if you want to go a little bit more advanced using formula, so this is a formula that you will have to memorize, and if you mess up the formula, then you're going to mess up the question. So that is one risk that you're going to take. But for the sum of natural numbers like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, you can keep a formula to get for a n value of natural numbers. You can get the sum from a formula, so you can use that to save some time. Or what you can even do is, for even this pyramid where we had the 4 into 1 plus 2 into 3 plus 3 into 2 plus 1 into 4, there's also a formula for that. So you can look into those if you prefer. But again, the disclaimer is that if you forget the formula or if you mess up the formula, the full question will go wrong. So instead of that, I prefer to just stick to these basic shapes like a rectangle, square, etc., because you simply know length into breadth or side into side is all you need to get your answer. So apart from that, let me see if there's any message over here. Outer is 13, inner is 4, total 17. Perfect. So any other issues by anyone? If not, we can call this end of the meeting.
Yeah, thanks, Avito.
Yeah, thanks,
I think we
Rakesh.
can-
Thanks, guys.